In this lecture, we will learn how to derive equation of electric field in a capacitor. We already know that capacitor is a combination of two conductors to relate the electric field E of between the plates of a capacitor to the charge Q. We will use Gauss's law. In electric field chapter, we learned that electric flux is equal to closed integral E dot dA. E is electric field. According to Gauss's law, electric flux is equal to Q upon epsilon naught. So we put Gauss's law in place of electric flux. Q upon epsilon naught is equal to closed integral E dot dA. Since electric field has uniform magnitude, it comes out of integral Q upon epsilon naught is equal to E closed integral dA. And the integral of dA is A. Thus our equation becomes Q upon epsilon naught is equal to EA. We rearrange this equation for electric field E. Our equation becomes E is equal to Q upon epsilon naught A. This is our final equation of electric field in a capacitor. With the help of this equation, we will derive equations of parallel plate capacitor and cylindrical capacitor as well. So keep this equation in mind for further derivations.